In this episode, we sit down with Madhav Singhal, who works on the data AI team at Replit. We discuss why integrating AI into software is the wrong way to think about it.
It's not a separate thing. It's like the product itself. Repl.it is AI in some sense, right? And that's been the dominant kind of training. And that says you should be burning as much GPUs as you're burning CPUs, right? And I think it's the correct heuristic, right?
How he thinks about data when training models.
One of the things I very carefully think about is this notion of entropy, which is like how much disorder am I introducing by adding this data, for example, or not cleaning this data in some way, or like when I'm going through samples by hand. I think about this notion of how hard is it making for the model to learn, for example. And if it's a very abstract thing, it's very hard to mathematically formalize it.
And his contrarian view on how people are building agents.
And I think it's interesting because it's going the wrong way. I'm a little opinionated there. I think that's what it's worth talking about.
Let's get started.
What is your theory of why physics is important to AI?
Yeah, I think I'll talk firstly about like the kind of like conceptual foundations physics gives, which like it gives you the right kind of toolkit to actually like think about these problems. That's the first layer of the conversation. And I think if physics is this thing, right, where you're trying to do this thing about conceptual analysis, which you're analyzing the world and concepts and analytically, but at the same time you have this empirical approach of testing. So it's like one of the few subjects which is like bringing these things together in very tight tandem, right? And you're not only like you're expressing, let's say, Newton's first law of motion in words, but also in equation, right? And there is this kind of like, like parallelism, which is like, being able to think quantitatively, but almost philosophically at the same time, right? And I think that gives you the right toolkit to think about problems. And more fundamentally, I think, a lot of these problems, like even the loss functions we use, right? Like a lot of them are inspired by statistical mechanics. Even Boltzmann machines and all came from, came from the world of physics, right? And so the kind of tooling you need, right? Be it information theory, being the particular statistics used, right? Being like thinking about distributions and stuff, right? Thinking about optimization, right? Like, optimization procedures and things like that. I think just physics gives you the right kind of intuitions, I think, about it. Like one very interesting example, I think Karpathy talks about this, like thinking about how loss is optimized is like, he thinks about it like as this ball rolling down, right? On this like complex like loss landscape, right? For example. And I kind of resonate it with quite a bit, especially like you have these concepts like entropy and so on, which give you very clear ways to like think about like, your machine learning problems. And that's my hypothesis. Like, it gives you the right foundations, like intellectual, like conceptual, mathematical, but also like the kind of problem, the shapes of the problems are similar, right? And then you can apply one to the other, right? And I think it's worked pretty, like a lot of good AI engineers and researchers come from this physics background. And I suspect that's the reason why.
That makes a ton of sense. So in your work now at Replit, have you used any of the frameworks or the ways of thinking from the things that you've learned in physics to actually help you on a specific problem?
Yeah, for sure. Totally. And we'll get into like how I think about modeling at Replit. But one of the things I think very carefully about is data. It's just like, what does it mean to have good, high quality data for training? And especially the kind of problems we solve where we're constrained on like, compute scales and we just don't want to throw like 100 billion parameter model at a problem, right? We think about, like, for example, data. And one of the things I very carefully think about, is when I make decisions about, okay, do I want this subset of data in, this subset of data out, multiple programming languages versus one programming language, and things like that, is this notion of entropy, which is like, how much like disorder am I introducing by adding this data, for example, or like, not cleaning this data in some way, or like when I'm going through samples by hand. I think about this notion of like, how hard is it making for the model to learn? Like, for example, like, and it's this very abstract thing. It's very hard to, mathematically formalize it. But that's one very clear example to me. And I just impute it. And I think I would claim it has helped us like, get higher quality data and like think about data more carefully.
How much of your time at Replit is spent thinking about data? I know you just released the new version of your 3 billion code generation model. Yeah, would love to hear a little bit more about that.
For sure. And so this is specific to the kind of problems, class of problems we solve. But I would say almost like 90% of my time as the machine learning person, like as the person who's responsible for training these models, I spend a lot of time thinking about data. And I'll just answer this question in order. So like the shape of the model, like what the model is, like training regimes, learning dynamics, and all those kind of things. You need to know those things. They matter, but like and like those things that are like, like the industry like kind of gets like centralizes around certain ideas, okay, know that, okay, we need to do these things. And then it becomes a matter of like, okay, do you get those things right? And you need to know how to tune those things. But the magic specifically for use cases, right? We're not building general models as such like ChatGPT, like we're building like these code completion models, for example, for very specifically to help users write code faster and more easily. It's like the magic there is entirely the data. It's like, okay, are you capturing all the languages? With simple questions like, are you capturing all languages that users want? But more so like, okay, are users like going to be using like, these kind of HTML pages, which are just like, just like have a lot of like repetition, for example, right? Or like, there are these like tail end of languages, like, the programming language D, for example, how much that is being used, right? Okay. Another thing is like for us is like, okay, a lot of people are actually building AI apps on Repl.it, so you better make sure that a significant percent of your data has these LangChain and, Llama Index kind of frameworks. So like, broadly, that's that. But 90% of the time in terms of like building a good model is purely about getting really good data. And that involves a lot of just like manual work. I'll be honest, like it sounds unsexy as anything, but it's like, going through data manually, getting a sense of like what are the kind of like, like bad samples which are there, how do you filter them out, thinking about, okay, what is the distribution of samples, like in terms of like programming languages, frameworks, like, is it good code, is it bad code, like doing a lot of deduplication. There is this idea in language modeling where you want to dedupe data a lot, right? You don't want to like make the model see like 200,000 examples of the same thing. It's not learning anything. It's just overfitting to it, right? So things like that. And I can go into more details, but 90% of the time is basically data quality, and like understanding, does this data make sense for the data that people want to use it on, like, in the product.
And it seems like this sentiment that like data is kind of the secret sauce right now is becoming more pervasive with the people that I've talked with. You're seeing big investments from like OpenAI. They're paying top dollar for data sets now that they didn't previously have access to.
Totally.
I'm curious, like, how do you see, I guess two questions here. How do you see this playing out in the short term? And like what sort of procedures or processes are you seeing teams adopt, or are you adopting internally to like help with your data gathering and cleaning? And then long term, how do you see synthetic data or LLM generated data playing into this?
Totally, yeah. And so I think for the first part of the question, like, gonna just borrow from what you said, is like, yeah, the most closest trend I see right now is synthetic data, which is like, like people synthesizing data as this kind of, almost pre-training, like to actually like teach their models, like, it's almost following this intuition, right? If you want to learn like physics or something, you first learn through a physics textbook, like from like the first year of college and then the fourth year of college and something like that, right? And so, for example, the code programming, like code completion language modeling case, it's like, you intuit that it's better that the model sees like textbooks of programming and code, right? And then it actually sees like thousands and millions of samples of like, like actually how to write that code, right? So I think the first thing, I totally agree with you, is like synthetic data is going to be big, and synthetic data, this textbook kind of fashion, is becoming a huge thing. Going back to what I was saying earlier, this entropy-like thing, like it, to some sense, it's easier to learn from, low entropy data like a textbook, right? The data set is meant to teach you about like broader high level concepts, such as like, recursion, things like that, instead of trying to like parse out what recursion is by like 100 million samples. So this synthetic data is becoming a huge thing. And, the next thing I think along the same lines is this curriculum learning thing. And so my personal opinion is like, a lot of people have like, talked about like sampling data correctly, data quality and stuff, but, there's this missing piece of like, ordering of data. So like, and you're already seeing this coming in with like instruction fine tuning and all. So people are taking all these base models and, running wizard LM style, like, eval instruct tuning, or, supervised fine tuning and chartifying models for your use case, right? It's almost like, they're teaching the model to like behave in a certain way post the training, right? And my suspicion is there are really good papers around it. There's this one I've been recently thinking a lot about. It's called the Skillet paper, which is like basically you teach skills. You have this notion, and they have a formal notion of what a skill is, but you teach certain skills first to the model, which help the model learn, more advanced skills, right? And they formalize these notions, right? And then they ablate and show that, okay, learning some prerequisite skills helps you learn these more complex skills later. So synthetic data combined with, this kind of curriculum learning, I'm very bullish on the curriculum learning. I think there's fundamentally this idea of like what order you teach. And it's very intuitive. I think, humans learn things in a certain order, right? Instead of just extrapolating from examples, we learn like the concepts first and then learn how to apply these concepts, for example. So those are the two big things. Yeah, I'll pause there. Yeah.
And then during your time training these models at Replit, what are some things that you learned about gathering and then cleaning this data internally, or things that were not obvious to you at the time?
Yeah, totally. And I think, so one thing was like, so I'll start with the first thing, which surprised me, which is like deduplication really, really helps. So, I mean, it's a well-known thing, but my perception of how much it helps changed a lot. And, like, deduplicating fuzzily, like for example, we focus a lot on that, deduplicating using embeddings and so on, like that's something which I saw in my ablations, which was very interesting. A lot of it is actually just like low level stuff. For example, when I was dealing with like Replit specific data, which is like for our internal models, we tune on Replit data. There's a certain kind of data, like we are seeing these patterns of repetition, right? And so like I'm almost going in and like actually designing heuristics to like filter out files which have like, less unique lines, right? Compared to some other file, right? And so a lot of it is like actually looking at the data and then designing like these kind of heuristics all along your samples. A lot of them like can be, for example, like, how much number of unique lines in the sample, what the alphanumeric ratio, such as like how many words are there to like, just digits or random symbols. For example, to eliminate minified files, heavily deduplicating, actually manually removing some samples. For example, you have like 15 ways to write Fibonacci function, and you make a decision about, okay, I don't want these 5 ways to go because they're just missing this edge case, right? Binary search has this problem, for example. So it's a lot about like getting a feel of your data and then designing these heuristics, which you can implement programmatically, because to clean 3 TB of data, you can't do it manually, right? And then, this multi-pass kind of approach to do it. Happy to jump into more details there, but like that's a high level organization of like how I think about like cleaning data.
Yeah, that's super interesting. Like you're essentially designing heuristics for identifying like high quality code, which is actually like really hard to do, right? Like you said, there's 15 different ways to do everything. There's edge cases that may or may not be handled that you have to like personally be aware of when you're looking at a specific example of code. There might be languages that you're unfamiliar with. Like how do you think about this problem holistically, like within the organization? Like what kind of tools have you guys developed to like sort through all this code and analyze this code and then do kind of like sanity checks? And you published your evals for the kind of final model that you guys released. But internally, what does that process look like to refine your data set over time and then test the model for improvements?
For sure. Yeah. So I'll divided the question into 2 parts. One is just like the data efforts, and then like, eval and measuring around these things, right? I think they're slightly distinct. So the first and the big thing for us in terms of process is getting good data infrastructure in place. So the unsexy answer is, okay, you have to build your pipelines which can process data at scale, right? So if I'm fundamentally positing that this is an iterative process where I'm looking at the data, cleaning it out, looking at the data, cleaning it out, I have to have a very fast feedback loop. And, speed is a feature. I think a lot of like people don't realize that is like, if I have a system which I can iterate very quickly with that, and I do multiple iterations, that like gives me a significant benefit of, like a perfect system, which takes more time, right? Because you learn with each iteration, right? Like instead of like thinking about everything up front and building an entire system. And for us, it's basically really investing in that data infrastructure. So we like design these abstracted pipelines, which we can run on multiple different data sets, actually spending the time, like low level time with like designing writing these low level Spark functions. And Spark is one of those technologies which is like, oh, why is it still here, right? But, for us, like, okay, we decided to bet on something, and it gives us the power and the expressiveness to actually write custom things. When you're designing your own heuristics, you can't just use like, functions out of the box, like from, like pandas or something like that. You have to literally write the algorithm on your own, for example, right? So like that's something like it's just a lot of algorithm writing, very much like lead code style kind of writing. You actually write algorithms which you learn in distributed ways. Which we implement a lot of tooling specific for code. For example, parsability. Like you don't want code which is not parsable going into the data, right? So okay, you want to take your entire massive data set and like remove everything which is parsable, for example, right? Remove everything which is auto-generated, right? Auto-generated code can occur in multiple different ways. You design like a mapping function which says, okay, tries to identify auto-generated code fuzzily and then filters it out. So the short answer is it's just a lot of low-level algorithmic writing. You just have to design the right algorithms for the heuristics based on the data you're seeing, and you build a good data infrastructure to like actually iterate through these things very quickly. So unsexy answer, but that's the honest answer. Yeah.
Do you guys ever drop to the AST level to do analysis on code, like when you're filtering it?
Yeah, so not always. Depends on the specific heuristic. So yeah, you want to know, okay, how many top level nodes in the AST are there, right? And like like if you're parsing, you automatically get some things out, right? So you know, okay, how many individual functions are there in the sample, for example, right? Like, is it just one massive script, or is it like multiple different, like, well abstracted out functions, right? For example. So those are the kind of things we do to like actually identify code quality a bit, because AST is the structured representation which helps. But we almost always use ASTs only to filter and like get data quality out. We never use AST as a feature. It's just like doesn't like we haven't felt the need to do so, right? It's just causal language modeling for these autoregressive model works really well. You don't have to prove, like, you don't have to feature engineer too much.
Interesting.
So we've talked at a low level about data. I would love to zoom out a little bit and talk about Repl.it at a high level and how you guys think about AI more generally. How do you think about AI at Repl.it?
Sounds good. And so I'll structure the answer in two parts. One is like, how do we think about the product level, and like, what does AI mean, like building AI at Repl.it mean for the users? And there's a second, more engineering kind of question, which is like, what does building AI mean at Repl.it, right? And then you can like direct me however you want me to answer it. So the first question is, how do you think about AI for the users, right? And I think I'm just going to echo Amjad here. Is like, like this idea of having different surfaces of AI integrated into product, I think is a paradigm so far, but like going forward, it's fundamentally like that AI is bottom up infused into your product. Like almost everything you do has some kind of like, generative AI or like, like embeddings or something like some aspect of like AI, quote unquote, broadly powering it. And so for us, we always think about it's like we don't think about designing like separate AI surfaces and there's a separate team working on it, right? It's like, okay, you have deployments, you have, the code editing experience, you have like the environment setup experience, and everywhere we want to think about like what is fundamentally like, this new technology enabling. So it's very much, it's not a separate thing. It's like the product itself, like, Repl.it is AI in some sense, right? And that's been the dominant kind of framing. And the that says, you should be burning as much GPUs as you're burning CPUs, right? And I think it's a correct heuristic, right? Because it's like, this is a new paradigm of software, right? And so the computation which is happening has to be like, it has to be tightly integrated, right? And it's happening as much as anything else. So that's the broad level view. And I think more broadly, we think it's like, the IDE of the future, and like we have this paradigm called ADI, right? And so the software development experience in the future is like AI is native to it, right? Be it like writing the code, be it running the code, be it debugging code, and all of that. And so, and for the users also, that means, okay, they don't need to be able to think about purchasing AI to develop software. Like it should be in the first place. And therefore this whole effort, like, AI for all, it's not simply like, and it's actually an engineering driven thing, which is like, you have to be able to serve these models cheaply. You have to have the infrastructure to do this at scale. You have to have it make economics, like meet the economic like requirements and like, make sense for the business as a whole. So across all these things, it's just like, it's not a separate thing. It's all coming together, and you have to solve the engineering problems to like make it happen for the user. Because at the end of the day, the user should not think about AI and software development as a separate thing. It has to be part of it, right? And it's going to be native, like, and we're betting very heavily on that.
You mentioned the economics making sense. And if you have AI, which is like part and parcel of your product, it's basically native and indistinguishable from your product. How do you think about making the economics work at Repl.it?
Yeah, and so I'll talk about it in a very specific case. So one of the reasons we like spend R&D effort in trying to get these very small but powerful models out is because to answer this economics question, right? So we turn these economics problems into engineering problems, right? Is it possible, as per the laws of physics, et cetera, and like, based on what the research says, that can we actually solve this economics problem of like giving everybody like code completion at scale without actually like, while maintaining a business incentives, right? And so for us, we always view these things. And, you have like there's news floating around, like Copilot is costly and, burning money and all of that. But like we think about these very bottom up, so instead of training a 175 billion parameter model, with just like any and all data and then trying to serve it to the users for code completion, we do experiments and we solve these engineering problems of figuring out, okay, if we have a 3 billion parameter model, given what we have seen and given what we test with the users, like, with like acceptance criteria and so on, we know that we can solve this problem, right? And we can get really good acceptance rates and we can actually solve a tangible problem for the user as the data shows without having to break the bank, right? And so then it becomes an engineering problem of, okay, if you're training a small model, how do we actually make the small model really good? It turns out the answer is high data quality, data repetition, like really understanding your learning dynamics. So like we do this thing, like, we train in a specific way. We have some tricks like learning rate cooldown. So like we almost always turn these into engineering problems, right? And like, the reality is, right, if you think about it from first principles, there are ways around it, right? So Repl.it's job is not to serve like, 300, 400 languages, but like, can we get it right on the bulk of the languages that users care about while maintaining a good user experience with latency and all of that? So it's like, it's this multi-dimensional trade-off where you think about it carefully, which makes sense according to research, and like you test with experiments. Like it's a very empirical thing. You test with a lot of like A/B testing and like training multiple models and averaging across them. And then that's how you give yourself confidence that you've actually solved the problem, right? So that's my take on it. These are fundamentally engineering problems, right? If there's no theoretical or, like limit as the laws of math or physics, you can always, there is some engineering trade-off you make to solve it.
Yeah, it seems like, so I think Code Llama came out maybe like 2 months ago or something like that. I mean, but pretty recently. Right. And that was kind of like state of the art for open source. That was a 7 billion parameter model. You guys came out with a 3 billion parameter model that's doing just as well. And so it's like it almost seems like we're on this exponential increase in efficiency, just in terms of performance to like model size. Do you see that trend continuing? Like, how do you guys think about taking what you've done so far and, improving that by an order of magnitude or more?
For sure, yeah. So I do think, to start with, I do think there's a bound to it. I don't think so. It's like it's going all the way. I don't think so. You can go all the way down to a 350 million parameter model, because I think you start running into these fundamental core issues of like information bottlenecks and all of those kind of things. Just thinking from first principles. But I do think there's a lot of scope in like making a 3 billion parameter model. I would wager like even up to like as good as like a 13 billion parameter model, as long as you keep like, the use cases scope tight, right? So if we're not trying to make a 3 billion parameter model just be chatty, like even though we have certain experiments to show that it can do it, like, but, we're careful about, like if it's not general enough, we don't want to release it, for example. But I would wager that there is a limit to it, but it'll continue growing. And, and the core driver of this will be, I think, just getting like the right data in place. That's something I know from my work, right? Like I know from my work, like, just getting data really, really good takes you, like, I think that's one of the core factors. I suspect there might be some other factors, there might be a new architecture tomorrow, which has the same kind of like much lesser compute budget, but which just has the right kind of learning properties, which works. And those things are harder to predict, I think, because it's just like those things happen in such wide, drastic steps. But my bet is it's going to happen. I think you can go a long way. There is a limit to it. But, and one of the core drivers, I think, based on my experience, is going to be data and data quality.
Interesting. And then how does open source fit into the strategy that you're talking about? So you mentioned like, you guys turned an economics problem into an engineering problem, trying to make these models smaller by sort of constraining the use cases a little bit and being really focused about what use cases you're actually serving. And that's gotten you really far. Why take that model and open source it? Like what do you guys get out of that? And what's sort of like I guess where do you see this going? Like if the goal of producing these models, smaller parameter models, is to save money ultimately, do you get to a point where you maybe have like a 1 billion parameter model that can actually be run locally, like in the user's browser or something, using their own hardware? Like how do you think about that long term?
For sure. So I'll tackle the first question first. It's like, why do we open source it, right? So I think, fundamentally, I think it's also just a framing of how we see what we use and what we open source. So for example, like the base model is trained on open source data. So the thinking is if you actually train on open source permissively licensed data, then it's the right thing to do to open source it, right? So that's a matter of principle, right? And that's one thing, right? But the big thing I think is there is like, when you open source these things, right, you get a lot of people building on top of it very, very quickly, and then you see more ideas being generated in the open source space, which actually ultimately benefit Replit as well. So, people will take models and build these local co-pilots, right, and design heuristics around it, right? And like suddenly, okay, you have a lot more people running like, local code completion, right, on the computers, and which fits into Replit's mission of, just like, even though it's not on the platform, it just makes sense, right? So I think those are the main reasons. And then I think there is also this trend in AI and like deep learning in general, where a lot of these things actually have come due to open source work, right? So PyTorch being open source, like, was a big thing, right? Because now you start like Facebook could have kept it closed, right? But like they get so many accruing benefits of like the community members contributing back to it. Like they're able to see what is more possible with like people just building on top of it and so on. And I think there are these non-linear effects when you like open source products and like, open source parts of software and people come together and build on it, right? And I think that's one of those things you always want to be betting for because it has such a non-linear kind of payoff, right? So it's it's hard to predict what it is, but it's still a good bet regardless. I'll pause there before I answer the second question. I see yourself on this thing. Yeah.
No, answer the second question. Then I have a follow-up about the phrase, it's hard to know how something will pay off. And so you should still bet on it. But yeah.
Yeah, totally. So Sam, could you just repeat the second question for me? So just make sure I capture it fully. I think I have a sense of it, but I want to be careful. Yeah.
Yeah. So talking about like local code completion problems, right? Like you guys are hosting these models yourselves now. Obviously, there's a cost associated with that. As these models become more efficient, they can run on, smaller pieces of hardware. Do you ever see a world where these models are actually being hosted locally and there's some sort of maybe browser API that's being accessed where the user runs the model locally and then like web apps can connect to it and, make calls that way?
Totally. So yeah, 200%. So like a few things I'm noticing in open source and just like the trend, so like projects like GGML are like, at the forefront of all these things, right? They're taking these big models, like quantizing them, like all these OS people are coming together and just like literally like solving hard low level problems to make them feasible on CPUs and so on. And I think, I definitely think that's going to happen, right? And right now we're in this phase of, general models, right? So one model is expected to do a lot, but especially when you move to task specific models, right? You're going to be able to reduce parameter count by a lot and write these like kind of, like low efficiency kind of like paradigms, like of quantization and so on. So I almost totally see, like small models running for different small use cases, be it in your browser environment or, be it locally in your computer, like, on an M1, like on an M1 Mac, with like MPS backends or something like that. I think it's going to happen both for, these 7 billion, 3 billion, like, even 30 billion kind of like, models, which we're already seeing with like GGML and stuff like that. And then more and more as these models become specific, right? Task constrained, just simply doing, for example, like speech to text, like Whisper or something like that, you'll have these like, you'll have this like kind of like families of models running, like right now these are like just like singular systems, but applications will be like compositions of these kind of like models running together, and then definitely you'll have like CPU like models running with very, very low resources. And open source efforts like ours are just like there's just like small steps towards like proving these things out, right? Okay, now you have a code model which is half the size but can like be very, very good for your use case, and you can probably LoRa it out and like, just use it very easily for your use case. So I think that's a huge thing. One quick note I wanted to make that for open source is like, we talk a lot about these open sourcing these models. Like a thing I'm seeing now is like open sourcing of data. So, a lot of people like on Hugging Face are actually like generating synthetic data and open sourcing these data sets, like, okay, you had these big efforts like Red Pajama and all going on, like starting all the way back from the pile, but you also have these like textbook synthetic data, and like you had models like Phi trying to do it. And now suddenly a lot of people are, publishing instruct fine-tuning data sets, like, the math, there is the recent math data set, for example, right? So not only you're going to just have open source models, but you're going to have open source data. And, I think that's where interesting things also start happening, because you start seeing smaller models, capable models, high quality data coming together, right? And then you can pick and choose some kind of mixture of data, which makes sense for your use case, put it together and train, right? And I think that's the another aspect of nonlinearity, which I think, is going to start coming up, like, which is like, data be high quality data, open source, which you can pick up and just like throw at it. Like it's almost like importing a library, right? So I'm super excited about that. Yeah.
You have these things working in parallel, which are maybe somewhat separate right now, but not entirely, which is like the open source data movement, and then the model optimizations that you can do just by like constraining the data sets. And it might not be obvious now how those things are going to bring all of this to the next level, but at some point there'll be a thread where it's like, oh, this is what we were looking for 3 years ago, and now we're 10 times further than we would be.
With this trend of people open sourcing their data and a lot of people doing the effort of actually cleaning the data and making sure that it's high quality, have you seen any interesting data sets that have popped up recently that you're either interested in trying out or just think open up a whole suite of new use cases now that this clean and high quality data exists?
For sure. So the particular ones I'm super interested in, like, there's this class of, textbooks kind of like data sets, synthetic textbooks like data sets. So there's a Hugging Face user, his user handle is VicP. He's like doing these like textbook quality programming ones and all of that. And like these people are very carefully think about like what does a textbook like curriculum looking like for data sets, and they're spending a lot of time cleaning that data and so on. So that kind of, almost like, as I talked about, like the early set of data, this textbook like quality or like, easy data to learn from kind of data sets which are coming up. Like that's something I'm interested in. I haven't like played around with them enough to like ablate and say, okay, like this plus like just normal core data versus normal core data works better. So, but my intuition is like, that's super interesting. That's worth like quickly trying. For me, that's the data which I'm interested in, like where you bringing like you're almost building out some sort of encyclopedias for models to learn from, right? And then obviously the second one is, like the second class of data sets are these like, fine-tuning data sets to like make models behave in a chatty way and, or like, respond in certain formats and so on that. Personally, I'm more interested in the former because that's where like the bulk of the language modeling happens. And then you can obviously adapt it to your use case. But yeah, there's a bunch going on and a lot of people are putting in work in it. I'm super excited to play around with those kind of data sets,
Yeah, that makes sense. And now that we're talking about the bounds outside of Repl.it and the things that other people are doing, what are some other interesting things that you've seen recently, whether that's research or interesting tools that you've tried out or interesting trends that you've seen?
One interesting paradigm, which, everybody's building products on, and I think it's interesting because it's going the wrong way. So I'm a little opinionated there, and like I think that's why it's worth talking about. Is this like paradigm of agents, right? So a lot of people suddenly like this huge movement, and I'm pretty much talking about like, to the tail end of the movement. It's like everybody's building these agents, agents to use the web browser, and line chain kind of agents, chatbot agents, and all of that. And I think that's interesting because, what you're almost trying to take is this like core language model, which almost behaves as this like kind of brain, which does these inferences, given this input, gives you an output to actually like wrangle it and build systems around it to like use like in applications, right? One of the things I think, and I actually think it's going, but I don't think it's going, I think the way most people expect it. And I think it's going to, or more so that I don't think so. This is just a matter of like, if we keep going the same way, we'll get to very useful software products. I think it's going to change. So the things I'm interested in is, it's like actually chunking, like moving away from the paradigm of a generalist agent to actually like partitioning it out into like specific agent workflows. As we at Repl.it, like we call these things like agent workflows. It's okay. You have to do debugging. It's not one agent which is doing code generation, code debugging, code explanation. It's like you have it's almost like you have multiple people who are very good for multiple specific jobs, right? And that's something I'm seeing that, and a lot of people are coming out and saying, okay, this is the right way for example, to do it, right? And so that's something I am interested in because I think that is the correct way to do it. And then you have people like designing, for example, in the programming space, people have like a self-debugger kind of loop, right? So like they're trying to like prompt engineer specifically to the code debugging use case. And I think that's where it starts getting more interesting, which is like you're almost trying to like get this conceptual framework of how to deal with the problem, specify the problem, and then build agents around it. So it's all, and that's what I would bet on, like, like ML is hard at the tail ends, and so the right way to do it is actually like build these agents. And so particularly what I'm interested in is like, okay, for these variants of problems, right? Like, if you want to build like a physics teaching agent, like how does that look, right? Versus, like, for example, like a programming debugging agent, or like, just like a English, or like a customer service, like for an airline kind of agent, right? And because it's almost, you're trying to identify properties specific to the problem space, abstract them out, and be building like these kind of fuzzy programmatic like closed loop systems around it. So it's almost it's this world of like, okay, you're trying to like build conceptual models of like how to solve specific problems. So that's my opinionated take. I think agents, like generalist agents, I personally don't think so that's the right way to tackle the problem. At least at Replit, we don't try to tackle it that way. And I'll be interested in seeing how people solve like specific things.
That's interesting. When you talk about breaking this into like breaking these agent workflows into different pieces, I think a lot of people right now are trying to build agents with more general models. So they're using GPT-4 and, they have different prompts that they use for maybe like different steps in the flow or that sort of thing. Do you see that actually breaking up into like different models? Like you have one model that handles like one step in a single flow and it's just really good at that one step? Or like how granular do you see these getting?
Yeah, no, that's a great question. And I think there's a hierarchy of like, this partitioning going on in my head. So firstly is like, there's like just the input signals, which you're giving for specific to the problem, right? So the kind of input you'll give, for example, in a code debugging context, let's continue with that. You're giving the error stack trace, you're giving some space, like, perhaps a notion of the program, you're giving past execution things, you're giving diffs and so on. That input looks fundamentally different from, for example, like an airline chat assistant, right? Where you probably want to like get a little bit of search history and so on. So the first level of partitioning for me is like, just what information is the system dealing with, right? What information is it trying to highlight, right? And that's the first thing. I think to some extent, I do think you're going to see like, these models like kind of breaking up into tasks. For example, like, for you might have a specific embedding model, right, to fetch the right context, right, for a specific use case, right? So I think that's what's going to start first, right? So it's almost like the pattern is like you have a big model and you're trying to like break the specific tasks into like these small models, right? So for a model which needs to convert like normal text into just JSONified text, yeah, you can use GPT-3 or 4 for that. But like, you can probably like use a smaller model, for example, right, while maintaining information. So I do think something like that's going to happen, but I think there's a lot of lift possible above, like, partitioning at the model level, just like dealing with the right kind of information and building the right kind of like flows around it. What information it's almost like designing a really good closed system where essentially the idea is, are you giving the right feedback and the right input signals back? And that's what I think will start first. But I totally agree with you. I think it's going to happen. Then you're going to have these small models, right? Speech to text will be a different model, right? Right. And it's interesting because OpenAI with GPTV and all these things is like, trying to amass a lot of it together, right? And I think this is something where I'm like, I bet on both sides of the coin kind of thing. It's like, yeah, there's also these emergent things, right, which are going on with these kind of like multimodal models. So I think for application specific things, you're going to have this like, this specialization, like especially in a product context. And, for more general things, you might go general. But, intuitions about these things, like, I keep evolving them over time because you see something like GPTV and then like, probably GPT-5 and you're like, okay, that's completely changed my mind, for example, right? So,
yeah, along that same line, like, how do you think about OpenAI right now? I mean, obviously everything they do is closed source. They're kind of like the 800-pound gorilla. They're releasing really cool models. It's kind of like, I think, what people think of when they think of LLMs, at least non-technical people or people that are just looking in from the outside. How do you guys think about, or I guess, how do you think about that personally in your own work? And then how do you think about, GPT-4 based products, something like Cursor that's also built specifically as like a, code augmentation tool?
Totally. So I'll give you my thoughts on OpenAI in general. And I think firstly, a lot of value with these kind of like, these kind of like big, like industry leaders is like, they kind of set precedent for a lot of things. And I think, one of the ways I think about it is like, okay, like what precedents are they setting and why? And like, where am I like with them or where I think it's like, doesn't make sense, right? So they were like, they bet big on scaling. Okay. So that's interesting. I look at that carefully and I was like, okay, it's not just scaling like the model size, but it's also scaling compute and, data, right? So it's like, okay, they're saying something very interesting there, right? Embeddings and like, the embedding APIs and that. So for me, what I see is like, what are the precedents they're setting from a research oriented kind of point of view is like, what are they betting on and why? Like, why did they bet on like, mixture of experts? Like, that's an interesting question to me, right? Like, is it like, they're just so betting heavily on like, modifying the architecture to just utilize more compute rather than, completely trying different architectures like graph neural networks or something else for fancy. So for me, that's always like it starts what they do starts out as a set of propositions, which I like think about very carefully. I do think this closed source stuff is interesting, and I think it's hard to say like there's a normative way you can look at it, which is like is it good for the world, is it bad for the world, and you can argue both sides of it. But I'm more interested in just like the influence of what companies like OpenAI or Anthropic even do to like where does the technology go, right? And like, the thing, like the negative way to think about it is like, are they all driving us towards a local minimum, right? Is the generative pre-trained transformer the paradigm which actually gives human civilization age, or is it something else, right? So in summary, I think, it's like, I'm just like the little guy who watches very carefully what they do and like think about very carefully about what they do. And a huge thing I think is, they've definitely instilled a lot of awareness, right? And like, awareness in the sense of like what is even possible, right? A lot of the products we are seeing right now, right? Like, fundamentally wouldn't be unlocked if you didn't have an API, just like per tokens, you're paying for a certain dollar per tokens per second, right? So for me, it's always this, as much as they do in research about like, what are they expanding? I always think a lot about, okay, they're actually also enabling, like they're also opening up the space of like what products are being built, right? And for me, like as an engineer, I think a lot about, okay, what are the problems they're solving for users? And I think that's very interesting, right? I'm pretty curious about like what will be like the kind of products people will build with like GPTV, for example, right? Like is it like education assistants, tutors, right? Or is it just like meme machines? You never know, right? But for me, there is just like this space of expanding new things in the world is something they drive very carefully, both in research and products. And like, for me personally, that's what I index on the most rather than anything else.
With the new vision model coming out, what are some ideas for products that do come to mind?
Yeah, for sure. So I think, so I'm a pretty visual learner, right? So I think there is this whole idea of like how humans like interface with information, and you have different modalities of it, like text, image, and so on, right? And I think there is this promise of building like universities will be dead, and AI will teach people, for example. That's one part, like which a lot of people centralize on, right? And so the first thing I would like probably think about is like it's like, is there a better tutor to like teach you physics, for example, right? I have a question, instead of just giving you text answer or equations that you have to read, you can draw a diagram, right? And this is just personally inspired from my kind of view, right? So I think, and the fundamental principle behind that is like you're augmenting like the bandwidth space of how you're communicating information, right? So for me, that's like the first kind of class of products I'm very interested in is like, these fields where you have this like kind of visual and textual kind of interaction. Like, can you build like really good learning agents around it? I think that's a common thing, but like, that's something I would really want. Like, I would pay for it if I could like learn something very, very quickly with this like kind of tutor kind of way. That's the first and the main kind of project thing which comes to my mind. I think the other thing is just, real world applications start becoming like more and more feasible, right? You want like to cook a recipe, can you take a picture of the food and like you have something coming around, like versus typing in what the name of the food is and then like having things. So my suspicion is like my bet is, I think for the kind of products people were trying to build with GPT-4, there is a subset of those products which suddenly become more realistic and more possible and much more like user friendly, which users would pay for with GPT. So that's something that's something. Those are the two things I come to my mind in terms of products. And
much more compelling too, especially when you have another modal. So back to the first thing that you said, which is the AI tutor. A lot of people usually default to like, hey, I want to learn X, and now that we have like vision, and now that we have like also audio, I can learn information in a totally new way that's more specific to me. Mm-hmm. One thing I find interesting is not specific skills or specific knowledge to be learned. It's actually like the role that parents or teachers usually play, yes, which is more so nurture and like human traits.
If you have some sort of like AI companion that grows up with you, like people right now have like dogs and teddy bears, but now with like LLMs and agents, you could feasibly have like a companion that grows up with you and kind of serves as a serves the function of a parent in helping you think through like specific problems related to, for example, like empathy or certain situations, like if you're being bullied or if you're bullying someone else. It's like all these non-tangible skills. And so I think that's also a particularly interesting area.
Yeah, no, totally. And like one of the ways my buddy and I talk about it is like, there's this fundamental aspect of metacognition that we all have to do in life. And, like you being able to think about your own thinking and how you're emotionally reacting to things and all of that, right? And like suddenly you have another agent in your life which can like do this metacognition for you, right? Like, like sure, you have other people who can like give you feedback on what you're trying to do, but like there's a piece of software which can also participate in this process. And that is super interesting, right? Because fundamental property of software, it has more persistent memory, right? It just has like, it can deal with a lot more information, right? With a lot more latency and so on. So what does that mean for your metacognition, right? So yeah, that's super interesting. I haven't given it much thought, but yeah, I suspect like we're going to have AI companions, and like character.ai and all are already like the retention numbers are showing that there's a shape of that, like, that phenomena occurring.
How do you think about how we interact with software? I feel like you've probably thought about this quite a lot, especially in the AI space, as now we have vision, we have text, we have audio, we have all these things. How do you think about that at a high level?
Yeah, totally. And I think there are multiple. I can go off quite a few ways, but like the thing I would bet a lot on, like, and I think this makes sense to me is like, when computers started, right? You have to, computers are these quote unquote intelligent entities which you have to deal with in very structured ways, right? So be it writing like punch cards in the future for in the past for like computing, like describing programs, to actually now writing a programming language which still has some structure and syntax to it, right? But I think like human beings fundamentally, when they communicate, like, there's this fluidity of structure to it, right? And sure, you can argue structure is better in some ways, right? But when I'm talking about ideas to you, I'm not going to say, oh, hey, here's how I'm going to talk about this idea. This is bullet 1, bullet 2, bullet 3, bullet 4, right? Or, or not, I'm saying like, referencing something and there is an import concept X happening. Like, it's like, I'm not explicitly referencing it, right? And I think the interface problem, how people will use computers is like, it's going to move away from this, like, start fitting to a structure of like, of user input and interface, like be it your terminal, be it even your mouse to the limit, right? Like clicking around on things, right? And you can talk about, things like it tracking your eye movement or, like hearing your voice and so on. So that's the high level pattern, right? And like, I suspect in the future, like, UIs will not look like, I'm going to like, Nike's website and like I'm navigating to find a particular shoe. In fact, it's more like, I'm going to the website and I type it and the UI shapes up around, for example, as a function of my query and the software behind it. So I think that the first thing is going to happen is in using computers, these steps of where you have to get to your final outcome, you have to go through these computations of interfacing with structured pieces of like, interfaces and things like that. I think that's going to completely go away. And, I think you're going to like reduce it, be it like a chat modality, be it like, just like communicating with images back and forth or just speech. I think it's going to be a synesthetic like experience. And I would almost like evolution has wired us to like, talk to humans. Like for us, the intelligent thing has always been humans, right? So I think, interfaces will start annealing to this kind of like shape or form where it starts looking like talking to a new user. Henceforth, you have like mentions of Jarvis, and it has a very anthropomorphized form, for example. So that would be my bet. But like the structure, we're interfacing with structure or like syntax, with compilability and things like that are going to get removed, in my opinion.
That's really interesting. Yeah, I mean, it seems like we kind of when we first started working with computers as humans, we all had to like learn this structure, and it was kind of I don't know, not intuitive at all to like use a terminal to like do things, and we're not none of us are old enough to remember any of that, but like as a species we're gonna have to like unlearn that and just go back to like how we standardly interact with each other. And I think it'll ultimately like lead to way more accessible tooling for like generalized, the generalized population. You'll be able to spin up websites really easily, maybe even build your own software. You mentioned like really personalized shopping experiences that help people find what they're looking for. I think all those things are on the horizon and probably not even that far away.
Yeah, totally. And we just see this all the time at Repl.it. More and more people are using like natural language as a way of like defining and describing computations rather than, just like writing like code, right? Even like, you just defining a function header and getting the function out with this code completion model is the way people write programs, for example, right? Or people say, oh, I'll write me a snake game in Python instead of, like having to write the code syntax. So like they're already moving above these levels of abstraction. You don't want to install a library. You don't have to go and like modify like, some structured representation of a PyProject file or something like that, So that's the thing I already see happening, and it's just that's where the leverage comes in, right? We talk about like, AI is helping programmers move faster because you can communicate a more high like you can communicate similar information in lower bits per se, right? For example, of just the instruction, right? And that gives you this leverage essentially. That's how I see it. Yeah.
So there's this phrase which is something along the lines of we shape our tools and our tools shape us. And as we move away from more structured, like a structured way to interface with our tools, I wonder if that changes the way that, one, we behave, and then two, the way that we think. For example, I remember my first computer science class and taking that and realizing like, hey, actually, this helps me think a lot more clearly because I have to think in a structured and logical way. And I wonder if we move further away from that into more things that are unstructured, does that change the way that we think, the way that we communicate, or even the way that we behave? I'm curious if you have any thoughts on that.
No, that's a great thought. And I can totally see what you mean because, one of the things I did a lot of logic and, there is this idea of like syntax giving rise to like, semantics and like, basically you follow these kind of like procedures to actually figure out like the ideas or the content of like, and what is true, which is fundamentally a semantic, for example, thing, right? And I suspect that's going to happen. I wonder like what does lack of structure mean here? And I think, for example, one of the ways is like, you would focus less on the presentation of the work or like making like what your output be amenable to like querying or like, being consumed in a certain fashion. And so you're more focused on what the content is rather than, the presentation of the content, for example, right? So like UIs will look very different and things like that. And I think, typing in a code editor might not just be like typing in words now, but, it'll look very, very different. You probably might not even see the code you're writing and things like that. And then what that means is you're attending to, pun not intended, but like, it's like attending to the like different things, like you're focusing on the wrong things, on the different things. For example, what the program does rather than what the program is. And they're two very fundamental concepts, right? Yeah, I do think about that a lot. One thing I can probably I see when I kind of like try to see how I'm thinking about problems is I've definitely become a more of a breadth first search thinker, which is like, for me now it's a lot more about like, being able to find the right idea and compose it with what I'm trying to do and bring it in what I'm doing, either be it through like ChatGPT or, like Ghostwriter or Replit AI, like all of that, instead of actually like, focusing on that one thing at a time. So like at a moment when I'm writing a program, even something I'm shipping to production, it's the thread which is going on in my head is not the sequence of instructions which the program is doing, but like the sequence of like one step above. It's like, okay, I need to finish this function to do this loading, and I need to do this. Like I need to like. Then I'm thinking at one, and then I'm more thinking about what is indexed in my head and pulling information. So fundamentally, I'm like operating at information at one level higher rather than to the specific task. So I'm not thinking about the next line of code I'm writing. I'm thinking about the next function I'm writing or the next thing which my program is doing. Right. And like that's changed. I can definitely see that in my thinking these days. Yeah.
That is so fascinating. I didn't even think about that. And because of that change, have you noticed anything as a result of that? Like any consequence, like first order consequences?
Totally. So the first big thing I've noticed is like, I just like can move faster in the sense that, like being able to like close the loop in terms of what I'm doing is much, much faster. So it's almost like, instead of like analytically describing each computation, I'm fuzzily putting things together and iterating. And so the kind of like, speed and correctness trade-off has changed a little bit, right? It's more like, okay, move faster and like, correct it. That's definitely, that's the thing. And the second thing is, I suspect I hesitate to make this claim, but it's like, there is this idea of, I'm starting to have a lot more lateral kind of ideas, which is like, I might be working in a data infrastructure kind of problem, but like, just like looking at Perplexity, like, searching something in Perplexity, or, it's like, I'm bringing in something completely different. I learned about this one, like, sliding window algorithm I'd use somewhere, right? And then I'm like, I can just bring it in. So I suspect, my brain is starting to more work at like a top level kind of indexing kind of way, in an indexing kind of way, rather than like, in like, just a depth first, like, descending down a particular stack kind of way. And it's just like, it has this starting to happen, this property where I'm seeing myself more open to and actually more likely to like, bring ideas from different things and like get them together, right? Yeah, I like, I haven't verified this claim, but I would suspect that's already happening.
That's really
That
cool.
is so
Yeah, I mean, I
cool.
think it kind of like the AI, like it frees us up to use our creative energy for, higher level things, right? More important things
Correct.
that are like where you're not thinking about like what's the next line of code I'm writing. You're thinking a step above, thinking about how you can connect different ideas. And I think a lot of like kind of new, interesting, sort of like emergent things come out of that over the long term. That
Absolutely.
might be hard to sort of conceptualize now, but you have ideas that you wouldn't otherwise have had just because you have like kind of more empty brain space to work with.
Totally. Yeah. And at Repl.it, like our whole thing, our pitch is like ideas to software fast, right? And this compass that, like this, what you're talking about, like being able to build things together is piece things together rather than like implement them it's exactly this compositionality of like, you're making larger and larger steps at a higher level, and so getting to your end very much more quickly rather than thinking about the next character you're typing or the next line of code you're typing, right? So yeah, I totally resonate with that, and like I think it's happening, and it's going to only accelerate, I think.
Well, I think that's the perfect place to end. I think we've brought it full circle with ideas to output
Software.
pretty fast.